Picture this: an astronomer peers through a telescope on a quiet night, only to realize that the phenomena they predicted for future centuries might be unfolding far sooner than anyone imagined. The cosmos, vast and mysterious, is brimming with events so extraordinary that they could change the way we see our universe forever. In this video, we are diving headfirst into the 15 most astonishing cosmic events that experts believe could happen in the not-so-distant future. From the return of legendary comets to the birth of artificial stars, and even the possibility of discovering a new Earth among the stars, each event is a doorway to a mystery that fuels our innate curiosity. The universe is not just a silent expanse of stars and galaxies. It is alive with motion, change, and stories waiting to unfold. So, as we embark on this journey through time and space, prepare to be amazed, intrigued, and perhaps even humbled by what lies beyond our blue planet. Stay with us as we explore the wonders that might not just transform our understanding of the cosmos, but also reshape the destiny of humanity itself. Now turning to the first event, let us talk about the return of Halley's Comet, one of the most famous celestial visitors in human history. Named after the astronomer Edmund Halley, who first calculated its orbit in the late 1700s, this comet has been captivating humanity for centuries with its rare and brilliant appearances. Halley's Comet is unique because it is a short-period comet that loops through our solar system approximately once every 76 years. Its next predicted visit is set for the year 2061. An event eagerly awaited by astronomers, space enthusiasts, and dreamers alike. Imagine standing under the night sky, watching a streak of light cross the heavens, just as countless generations have done before us. From the ancient Chinese astronomers who meticulously recorded its appearances in the skies to the awe-struck crowds of 1910 who believed it might be a harbinger of change, Halley's Comet has always held a special place in our collective imagination. Many still recall its most recent visit in 1986, when telescopes and spacecraft provided humanity with its first up-close observations of a comet. The images of its icy nucleus and glowing tail sparked a scientific revolution in our understanding of these cosmic travelers. But here is where things get even more exciting. By the time Halley's Comet returns in 2061, our technology will have advanced far beyond what was available in the 80s. Imagine the possibilities. Sophisticated telescopes, advanced spacecraft, and even artificial intelligence could provide us not just clearer views, but revolutionary insights into its composition, behavior, and origins. It could also become a cultural phenomenon once again, inspiring art, music, and even space tourism as people from around the world gather to witness its rare and magnificent passage. The return of Halley's Comet is not just an astronomical event. It is a time capsule that links us to our past and propels us forward into the future. As we look to the skies in anticipation, we are reminded of the connection we share with our ancestors who witnessed it before us, and with future generations who will marvel at it long after we are gone. Moving forward, let us now unravel another astonishing cosmic event that could equally capture our imaginations and potentially reshape our world. Moving forward, let us explore the phenomenon of a solar superstorm, an extraordinary yet potentially disruptive event originating from the very heart of our solar system, the Sun. Solar storms occur when the Sun unleashes bursts of energy in the form of solar flares and coronal mass ejections, ejecting vast amounts of charged particles into space. These particles travel across the solar system and can collide with Earth's magnetic field, causing geomagnetic storms. While most of these storms are mild and even create the stunning auroras near our poles, a massive solar superstorm could be an entirely different story. Scientists have identified historical examples of such events, with one of the most well-known being the Carrington event of 1859. Back then, the impact was observed through telegraph systems sparking and failing, along with extraordinary auroras bright enough to be seen as far south as the Caribbean. But today, our world is far more interconnected and reliant on technology than it was over 150 years ago, and the consequences of a similar event would be far-reaching. Imagine the disruption to satellite communications, which govern everything from global positioning systems and telecommunications to financial transactions. Power grids could face widespread outages lasting days or even weeks, potentially leading to economic losses on an unprecedented scale. Even spacecraft and astronauts in orbit could be at risk from heightened radiation levels. With our modern dependency on such systems, the stakes are higher than ever. This is why organizations like NASA and other space agencies are monitoring the sun closely, utilizing satellites and ground-based observatories to study solar activity. One of NASA's key missions, the Parker Solar Probe, is currently flying closer to the sun than any spacecraft in human history to gather invaluable data about its behavior. By understanding the mechanisms driving solar storms, scientists hope to improve forecasting and develop strategies to mitigate their effects, such as hardening infrastructure and creating early warning systems. While the possibility of a solar superstorm remains a reminder of the sun's astonishing power, it also drives innovation and preparation that could help ensure humanity's resilience in the face of cosmic challenges. And as we continue this journey through the mysteries of the cosmos, let us now turn our gaze to the stars and the intriguing flare activity of Proxima Centauri, the closest stellar neighbor to our Sun. Now turning to Proxima Centauri, the closest star to our Sun and a fascinating subject of astronomical study. Sitting just over 4 light-years away, Proxima Centauri is a red dwarf star, much smaller and cooler than our Sun. Yet it harbors an extraordinary secret. It frequently emits powerful stellar flares. These flares occur when magnetic energy stored in the star's atmosphere is suddenly released, sending bursts of radiation and charged particles streaming into space. Observations have revealed that Proxima Centauri's flares can be tens to hundreds of times more energetic than the strongest solar flares ever recorded on Earth, making them both intriguing and hazardous phenomena. Recent studies have shown that these flares can significantly impact the star's surrounding planets, including Proxima Centauri b, a potentially Earth-like planet orbiting within the star's habitable zone. While this planet's location might suggest it could support liquid water and perhaps life, the intense radiation from Proxima Centauri's flares could strip away its atmosphere over time or make its surface an inhospitable environment. Similar investigations have uncovered that even brief exposures to such flares might bombard the planet with ultraviolet and X-ray radiation at levels far exceeding those experienced on Earth, posing challenges for the possibility of life as we know it. Yet the story doesn't end there. These flares also play a crucial role in understanding the dynamics of red dwarf stars, the most common type of star in the universe. Their prevalence means that many of the exoplanets we discover orbit such stars, making it vital to understand the effects of stellar activity on planetary environments. Astronomers are watching Proxima Centauri with great interest, using advanced telescopes and observatories to capture detailed data on its flare activity. This includes instruments like the James Webb Space Telescope, which could help uncover whether Proxima Centauri b or any other planets in its system retain atmospheres or show signs of resilience against such extreme conditions. As we continue to search for life beyond Earth, Proxima Centauri challenges us to rethink our assumptions about what makes a planet habitable. Its flares, while destructive, also open doors to questions about how life might adapt to, or even thrive under, conditions radically different from those on Earth. Exploring these possibilities only deepens our understanding of the cosmos and our place within it. With that in mind, let's now explore an equally groundbreaking frontier scientist's ambitious pursuit of creating the very first artificial star. Moving forward, we turn to an astonishing scientific endeavor that could redefine how humanity interacts with the cosmos, the creation of the first artificial star. This groundbreaking pursuit revolves around nuclear fusion, a process that powers natural stars like our Sun by fusing atomic nuclei to release immense energy. Scientists have long sought to replicate this process on Earth, not only as a potential source of nearly limitless clean energy, but also as a means to deepen our understanding of stellar phenomena. At the heart of this effort are experimental facilities like the International Thermonuclear Experimental Reactor, where researchers are pushing the boundaries of fusion technology. By generating temperatures hotter than the core of the Sun and containing plasma within powerful magnetic fields, they aim to sustain controlled fusion reactions. Success in this field could unlock a revolutionary energy source, producing no greenhouse gases and leaving behind minimal radioactive waste, addressing some of humanity's most pressing energy concerns. But the implications extend far beyond Earth. Imagine a future where artificial stars illuminate the path for deep space exploration. These fusion-powered light sources could serve as beacons, energy hubs, or even experimental platforms in space, enabling scientists to simulate and study star-like conditions much closer to home. Such advancements could provide new insights into the life cycle of stars, the behavior of plasma, and the mechanisms driving energy production on a cosmic scale. Moreover, the ability to create and control artificial stars could inspire unprecedented engineering feats, fostering innovation in materials science, energy storage, and space infrastructure. This ambitious project symbolizes a fundamental shift in how we perceive and interact with the universe, moving humanity from mere observers to active participants in the processes that shape the cosmos. As we look to the stars, both natural and artificial, the possibilities seem limitless. And speaking of celestial phenomena that inspire awe and demand attention, let's now journey to an extraordinary event awaiting us in the not-so-distant future, the near-Earth flyby of asteroid Bennu. Now turning to one of the most intriguing celestial objects in our solar neighborhood, asteroid Bennu, a remnant from the earliest days of our solar system. This near-Earth asteroid, roughly as tall as the Empire State Building, has captured the attention of scientists and the public alike because of its close approach to Earth predicted for the year 2135. While the chances of a direct collision with our planet remain low at just 1 in 2,700, the mere possibility has prompted extensive research and monitoring. At the forefront of this effort is NASA's OSIRIS-REx mission, which made history by successfully collecting samples from Bennu's surface in 2020. This ambitious mission has provided unprecedented insights into the asteroid's composition, revealing the presence of water-bearing minerals and organic molecules, key ingredients in the chemistry of life. Such discoveries not only shed light on the building blocks of our own planet, but also provide critical data for modeling Bennu's future trajectory. Understanding its orbit with pinpoint accuracy is crucial for predicting and potentially mitigating any risk it may pose in the distant future. Beyond its scientific importance, Bennu's story has sparked public fascination, highlighting the need for ongoing asteroid monitoring programs. These initiatives, employing ground-based telescopes and space missions, aim to detect, track, and study near-Earth objects that could one day threaten our planet. Asteroid Bennu serves as a stark reminder of Earth's vulnerability in the cosmic arena, as well as humanity's growing capability to protect itself through ingenuity and collaboration. And as scientists continue to analyze the samples brought back by OSIRIS-REx, one cannot help but wonder what secrets this ancient wanderer still holds. With Bennu's story setting a precedent for proactive planetary defense, let's now shift our focus to a search that has the potential to transform humanity's future, the discovery of a truly habitable exoplanet. With the next phase of the journey in sight, we turn our gaze to the tantalizing quest for a habitable exoplanet, a new Earth among the stars. This search has captured the imagination of scientists and dreamers alike, driven by the possibility of finding a world that could sustain life as we know it. At the heart of this endeavor are groundbreaking instruments like the James Webb Space Telescope, which has already begun revolutionizing our understanding of distant planets. Unlike any telescope before it, this marvel can analyze the atmospheres of exoplanets orbiting stars hundreds of light years away. By detecting key elements like water vapor, carbon dioxide, and methane, the telescope provides clues about whether these distant worlds might harbor the conditions necessary for life. Imagine the day when astronomers discover a planet not only similar in size to Earth, but also nestled in the Goldilocks zone, a region around a star where temperatures are just right for liquid water to exist. Such a revelation would mark a monumental turning point in human history, altering how we view our place in the cosmos. It would raise profound questions about life beyond Earth and perhaps even about our own origins. With advancements in technology accelerating rapidly, some experts believe that humanity could identify its first truly habitable exoplanet within the next few decades. The implications of such a discovery are staggering, from inspiring interstellar exploration to offering a potential second home for future generations. While the search continues, each passing year brings us closer to the possibility of finding our cosmic twin, a planet that could forever redefine our understanding of life's potential in the universe. And as we ponder the significance of such a discovery, let us journey next to a cosmic phenomenon closer to home yet just as captivating, the mysterious future of the star Betelgeuse. With the next phase of the journey in sight, we turn our attention to Betelgeuse, a star that has fascinated humanity for centuries. This colossal red supergiant, visible from Earth without a telescope, has been behaving in ways that have left scientists both intrigued and puzzled. Located in the constellation of Orion, Betelgeuse has exhibited unexpected dimming and brightening over recent years, phenomena that have sparked widespread speculation. Some researchers suggest these fluctuations could be caused by the star ejecting massive amounts of gas and dust, temporarily obscuring its light. Others believe they may signify that Betelgeuse is nearing the end of its life, a dramatic conclusion that would result in a supernova explosion. When a star like Betelgeuse reaches this stage, its core collapses under immense gravity, triggering an explosion so powerful that it outshines entire galaxies for a brief moment. Such an event would be a monumental spectacle for observers on Earth, lighting up the night sky in a way unseen for generations. If Betelgeuse were to go supernova, it would pose no direct threat to our planet due to its safe distance of over 600 light years, but the sheer brightness and intensity would be unforgettable. For scientists, it presents an unprecedented opportunity to study the life cycle of massive stars and the origins of elements heavier than iron, many of which are forged in supernova explosions and later become building blocks for planets and even life itself. For stargazers and enthusiasts, the sight would be awe-inspiring, a reminder of the immense power and beauty of the universe. Although predicting exactly when Betelgeuse will go supernova is incredibly challenging, the possibility that it could happen within our lifetime keeps astronomers watching closely. And as we marvel at Betelgeuse and its mysterious behavior, our journey moves next to a force of nature that affects not a single star, but the very planet we call home, the potential reversal of Earth's magnetic field. Now turning to Earth's magnetic field, we uncover a phenomenon that has shaped our planet's history in ways both subtle and profound: its polarity reversals. Earth's magnetic field, generated by the molten iron movements in its outer core, acts as a protective shield against solar radiation and cosmic particles. However, this shield is not static. Evidence in ancient rocks reveals that the magnetic poles have flipped countless times over the course of hundreds of millions of years. These reversals, known as geomagnetic reversals, occur irregularly, with the last one taking place roughly 780,000 years ago. Scientists believe we may be overdue for another flip, though predicting exactly when this might happen remains a challenge. During a polarity reversal, the magnetic field weakens significantly, potentially exposing Earth to higher levels of harmful cosmic radiation. Such an event could disrupt animal species that rely on the magnetic field for navigation, such as migrating birds, sea turtles, and even certain bacteria. Moreover, our reliance on satellite systems, power grids, and communication networks could face unprecedented challenges, as a weakened magnetic field would leave these technologies more vulnerable to solar storms. To better understand this process, scientists are closely monitoring the South Atlantic anomaly, a region where Earth's magnetic field is unusually weak and may hint at the early stages of a reversal. Advanced studies and simulations provide valuable insights, but the complexity of Earth's core dynamics makes this one of the most unpredictable phenomena in geophysics. While the prospect of a magnetic field reversal brings potential risks, it also offers a window into the inner workings of our planet, reminding us of the interconnectedness of Earth's systems. And as we contemplate these hidden forces deep within our world, our journey now takes us away from our planet to consider an expansion far more cosmic in scale, the accelerating growth of the universe itself. As the next challenge unfolds, we step beyond our planet and into the grand theater of the cosmos to explore a phenomenon that has puzzled scientists for decades, the accelerating expansion of the universe. This revelation dates back to the late 20th century, when astronomers studying distant supernova made a groundbreaking discovery. Not only is the universe expanding, but the rate of this expansion is speeding up over time. This was unexpected and transformative, as it overturned the long-standing belief that gravity would eventually slow the expansion down or even reverse it. At the heart of this mystery lies something scientists call dark energy. Though its nature remains elusive, dark energy is believed to make up roughly 70% of the universe. It is the invisible force driving galaxies apart faster and faster, reshaping the cosmic landscape in ways we are just beginning to understand. This idea raises profound questions about the ultimate fate of the universe. Will it continue expanding forever, eventually becoming a cold, dark expanse as galaxies drift too far apart to interact? Or will the accelerating expansion slow down or take an entirely unexpected turn? To address these questions, upcoming advancements in observational technology are set to play a critical role. Future telescopes and missions aim to study the properties of dark energy with unparalleled precision. By observing distant galaxies and cosmic phenomena, scientists hope to unlock clues not only about the nature of dark energy, but also about the origins and destiny of the universe itself. This accelerating expansion challenges everything we thought we knew about the cosmos, compelling us to rethink fundamental assumptions about how the universe operates on its grandest scales. And as we ponder the mysteries of dark energy, our journey will next take us toward a future collision of unimaginable proportions where our very own Milky Way and the Andromeda Galaxy are destined to merge in a cosmic ballet billions of years in the making. With the next phase of the journey in sight, we witness a cosmic event so vast and transformative that it defies the scale of human imagination, the impending collision between the Milky Way and the Andromeda Galaxy. This monumental event, set to take place around 4.5 billion years from now, represents the slow and inevitable dance of two colossal galaxies drawn together by the unyielding pull of gravity. As the galaxies approach each other, their shapes will distort, their stars will scatter, and their spirals will unravel, creating a breathtaking display of celestial chaos that will span millions of years. But contrary to what one might expect, most individual stars within these galaxies will not collide directly due to the immense distances separating them. Instead, gravitational forces will weave a stunning tapestry of interactions, as new stellar formations emerge and existing stars are flung into vast, uncharted regions of space. This merger is predicted to form an entirely new galaxy, often referred to by astronomers as Milkomda, a colossal elliptical galaxy that will redefine the structure of our cosmic neighborhood. For any civilizations that might exist in the distant future, the night sky will be a spectacular canvas illuminated by a profusion of star clusters and brilliant nebulae. While the Earth itself may no longer be habitable by this time due to the Sun's evolution, the legacy of the Milky Way will live on through its union with Andromeda, marking a profound transformation in the history of the universe. This cosmic ballet reminds us of the dynamic and ever-changing nature of the cosmos, where even the seemingly fixed stars and galaxies are part of an endless cycle of destruction and creation. And as we marvel at the enormity of this future collision, our gaze shifts to another fascinating phenomenon, one where stars burst into life at an extraordinary pace, giving rise to the brilliant phenomenon of a starburst galaxy. Now turning to the captivating phenomenon of starburst galaxies, these are extraordinary cosmic regions where stars are born at an accelerated rate, sometimes hundreds of times faster than in normal galaxies. This intense surge in star formation often transforms such galaxies into some of the brightest and most dynamic structures in the universe. But what triggers such a dramatic event? For many starburst galaxies, this phase begins when two galaxies collide or pass close to each other, disrupting gas clouds and igniting a cascade of star-forming activity. Others may experience a gravitational disturbance or internal instability that compresses their gas reserves, fueling this rapid stellar production. One famous example is the Cigar Galaxy, officially known as Messier 82, which showcases colorful plumes of gas and dust propelled by intense stellar winds from massive young stars. Astronomers are always on the lookout for which galaxy might next enter this extraordinary phase. Many speculate that intense interactions within galaxy clusters or smaller mergers could set off new starburst activity in the near future. Beyond their visual appeal, studying starburst galaxies provides valuable insights into the life cycle of stars, the distribution of cosmic elements, and the dynamic forces shaping galaxies over time. These galaxies also serve as natural laboratories for exploring conditions similar to those that may have existed in the early universe, offering clues about how galaxies like our own Milky Way evolved. Observing them through advanced telescopes enables researchers to witness the complex interplay of gravity, gas, and radiation in real time, deepening our understanding of the forces that sculpt the cosmos. With their dazzling brilliance and scientific significance, starburst galaxies remind us of the vibrant, ever-changing universe that surrounds us. As we continue to uncover their mysteries, we find ourselves drawn to yet another marvel of space, one that brings us closer to the edge of possibility, the creation of the first space elevator. Moving forward, let's delve into one of the most ambitious and futuristic projects humanity has ever envisioned: the creation of the first space elevator. Imagine a structure so monumental that it stretches from Earth's surface all the way into orbit, enabling people and cargo to be transported into space without the need for rockets. While this might sound like pure science fiction, researchers and engineers are actively exploring the feasibility of building such an extraordinary system. At the heart of the space elevator concept is a tether, anchored to a platform on Earth's equator with the other end extending into space, counterbalanced by an object in geostationary orbit. This tether would allow specially designed climbers to ascend and descend at a fraction of the cost and energy required for traditional spacecraft. However, constructing this marvel of engineering is no small feat. One of the biggest challenges lies in creating a material strong and lightweight enough to form the tether. Scientists are exploring advanced materials like carbon nanotubes and graphene, both of which show incredible promise due to their unparalleled strength and flexibility. But even with cutting-edge materials, designing a tether that can withstand Earth's gravity, atmospheric conditions, and orbital forces remains a monumental task. Beyond the tether, the space elevator would also require breakthroughs in robotics, energy transfer systems, and orbital mechanics to ensure its functionality and safety. Despite these challenges, progress continues. Several space agencies and private companies are funding research into the necessary technologies, and some experts predict that we could see a working prototype within the next few decades. If successful, the space elevator could revolutionize space travel by drastically reducing costs and making space more accessible. It could enable permanent space stations, facilitate the mining of resources from asteroids, and even support the construction of colonies on the Moon and Mars. More than just a technological leap, the space elevator represents a step toward a future where humanity becomes a truly spacefaring civilization. As engineers and scientists push the boundaries of what is possible, we are reminded that the sky is no longer the limit. With this bold vision in mind, let us now shift our gaze toward another fascinating chapter in humanity's journey through the cosmos, the sun's unexpected cooling trend. Now turning to the next cosmic revelation, let's explore the intriguing phenomenon of the sun becoming cooler. Our sun operates on a roughly 11-year cycle of activity, during which solar energy output fluctuates. This cycle is driven by the sun's magnetic field, creating periods of heightened activity known as solar maximums and quieter times called solar minimums. Scientists studying the sun's current cycle have noticed something unusual. It appears the sun might be heading toward a period of significantly reduced activity, reminiscent of a historical event known as the Maunder Minimum that occurred between the 1600s and 1700s. During this time, an extended solar minimum coincided with what many refer to as the Little Ice Age, a period where global temperatures dropped, leading to harsher winters and shorter growing seasons. So, what could a similar cooling trend mean for us today? For Earth's climate, a reduction in solar activity could bring temporary cooling effects, potentially counteracting some of the warming caused by human activities. However, the impact may vary widely depending on other factors like greenhouse gas levels and atmospheric conditions. On a broader scale, the effects of reduced solar activity extend beyond temperature changes. For instance, a less active sun produces fewer solar flares and coronal mass ejections, powerful bursts of energy that can disrupt satellite communications and power grids on Earth. While this might reduce the threat of space weather interruptions to our technology, it could also weaken the sun's protective influence against cosmic rays, allowing more of these high-energy particles to reach our planet, which may affect astronauts and space missions. Interestingly, such a cooling phase might also present opportunities. Reduced solar activity could allow scientists to study the sun's behavior in detail, gaining valuable insights into its long-term patterns and their influence on Earth's climate. Additionally, this quieter solar period might provide a safer environment for launching and operating spacecraft, fostering advancements in space exploration. As researchers monitor the sun's activity with increased precision, using advanced instruments like the Parker Solar Probe and the Solar Orbiter, they continue to uncover new details about its complex dynamics. These findings not only deepen our understanding of our closest star, but also help prepare us for potential challenges and opportunities arising from its ever-changing nature. And as we ponder the possibilities of a cooler sun, our attention shifts to the discovery of interstellar visitors, a reminder of the vast and mysterious universe waiting to be unraveled. Now turning to the next fascinating chapter, let us unravel the mystery of interstellar objects, cosmic wanderers that venture into our solar system from distant star systems. Back in 2017, the scientific community was electrified by the discovery of Oumuamua, a peculiar interstellar object unlike anything encountered before. Its elongated shape and unusual acceleration sparked debates about its true nature, with some even speculating it could be an artifact of extraterrestrial technology. Then, just 2 years later, Comet Borisov was identified, offering a more familiar yet equally intriguing glimpse into material from another star system. These discoveries mark the dawn of a new era in astronomy, proving that interstellar objects are not rare, but instead we are just beginning to develop the tools to spot them. So, when might the next interstellar visitor make an appearance? Scientists predict that with advancements in sky surveying technologies, such as the Vera-Rubin Observatory, it is only a matter of years before we detect more of these elusive travelers. Unlike traditional telescopes, this new generation of instruments can scan vast areas of the sky rapidly and repeatedly, greatly increasing the chances of catching interstellar objects in action. But what makes these cosmic visitors so compelling? Each one carries within it a time capsule of the conditions and materials present in its home star system. Analyzing their composition could unveil secrets about how planets and stars form, and even offer hints about the potential for life beyond our solar system. For example, scientists studying Comet Borisov found traces of carbon monoxide in much higher concentrations than comets native to our solar system, implying that its origin environment was far colder than anywhere near our Sun. By studying the next interstellar object in even greater detail, researchers aim to piece together more clues about the diversity of star systems throughout the universe. Excitingly, upcoming missions are being designed to intercept these objects while they are still within reach. Concepts like sending fast-moving probes to rendezvous with interstellar visitors could allow for close-up analysis, revealing surface features, chemical makeup, and possibly even organic compounds. Such missions would not only deepen our scientific understanding, but also potentially redefine our perception of life's possibilities in the cosmos. The arrival of the next interstellar object is not just an astronomical prediction, it is a chance to explore the unknown and connect with a broader cosmic story. As we await this next encounter, our gaze shifts forward to the groundbreaking telescopes poised to transform our understanding of the universe. With the next phase of the journey in sight, let us marvel at the groundbreaking telescopes poised to redefine humanity's view of the cosmos. These next-generation observatories, like the Extremely Large Telescope and the Nancy Grace Roman Space Telescope, represent the pinnacle of human ingenuity and determination to explore the unknown. The Extremely Large Telescope, currently under construction in the Chilean desert, will be the largest optical telescope ever built. With a mirror measuring over 100 feet across, it will offer unprecedented resolution, capable of capturing the faintest light from the earliest galaxies formed after the universe's birth. This telescope is expected to answer long-standing questions about the nature of dark matter and dark energy, the mysterious forces that make up most of the universe yet remain poorly understood. On the other hand, the Nancy Grace Roman Space Telescope, named in honor of a pioneering astrophysicist, is being designed to expand our knowledge of exoplanets and the accelerating expansion of the universe. Equipped with a powerful wide-field camera, it will survey vast portions of the sky, identifying thousands of planets beyond our solar system and mapping the large-scale structure of the cosmos. Its ability to detect planets by observing the slight bending of light caused by their gravitational field, a technique called microlensing, will uncover worlds that other telescopes cannot. These telescopes are not just scientific tools, they are time machines allowing us to peer billions of years into the past and piece together the story of how galaxies, stars, and planets came to be. They could even detect the chemical signatures of life in the atmospheres of distant worlds, a discovery that would forever alter our understanding of our place in the universe. With their immense capabilities, these instruments promise to push the boundaries of what is possible in space exploration, unraveling mysteries that have eluded scientists for centuries. As we stand on the brink of these remarkable advancements, one cannot help but feel an overwhelming sense of wonder. What secrets will these telescopes uncover about the vast, beautiful, and enigmatic universe that surrounds us? With these questions in mind, let us look forward to a future where the stars themselves may reveal answers to the deepest cosmic riddles. Now turning to the timeless marvel of Halley's Comet, let us explore the rich tapestry of its cultural and historical significance, as well as the awe it inspires in stargazers across generations. Halley's Comet has been lighting up humanity's imagination for centuries. Its dependable return every 76 years has connected generations who have gazed up at its luminous tail streaking across the sky. Ancient civilizations tracked and recorded its appearances, often associating it with mythical portents or celestial omens. For instance, Chinese astronomers meticulously documented sightings of the comet, while a depiction of it is famously found in the Bayeux Tapestry, memorializing the Norman conquest of England in 1066. Mark Twain, the renowned writer, even linked his life's journey to Halley's Comet, having been born during its 1835 appearance and passing away shortly after it returned in 1910. Looking ahead, its next anticipated visit in the year 2061 will arrive in a vastly different era of human history, with advanced telescopes, spacecraft, and collaborations between nations poised to study it more closely than ever before. Instead of just being a celestial wonder observed from Earth, future generations might send missions to the comet, analyzing its composition up close to unlock secrets about the early solar system. Its return could also serve as a unifying event, reminding humanity of its shared existence under the same vast sky. Imagine schools, observatories, and online platforms teeming with programs designed to educate and inspire young minds as they witness this cosmic phenomenon. It's not just a comet, it is a bridge between our past and our aspirations for the future. Perhaps in 2061, the sight of Halley's Comet will ignite the dreams of future scientists, engineers, and explorers, motivating them to reach for the stars just as it has done for centuries. As we marvel at this celestial visitor and its profound impact on human culture, we also look forward to the role it will play in inspiring generations yet to come, serving as a luminous reminder of the boundless wonders of our universe. As the next challenge unfolds, let us delve into the electrifying yet perilous phenomenon of solar superstorms. These cosmic outbursts, often stemming from intense solar activity, have the potential to disrupt life as we know it on Earth. Imagine this, a massive wave of charged particles from the Sun racing toward our planet, capable of overwhelming Earth's magnetic field and unleashing chaos on modern technology. Events like these, though rare, have occurred before. For instance, the Carrington event of 1859 disrupted telegraph systems worldwide, an era when such technology was in its infancy. Fast forward to today, where we rely on a web of satellites, electrical grids, and communication networks. A similar event in our modern era could cause widespread blackouts, disable essential systems, and cost trillions in global economic damage. The risks are staggering, but so are the strides humanity is taking to prepare and protect itself. Space agencies like NASA and the European Space Agency have developed specialized satellites to monitor solar activity in real time, providing crucial early warnings of potential superstorms. These observational tools help scientists identify coronal mass ejections, the primary drivers of such storms, and predict their arrival times with growing accuracy. But the advancements do not stop there. Engineers are designing resilient power grids that can withstand geomagnetic storms, incorporating fail-safes to prevent widespread outages. Governments and private companies are also working collaboratively on space weather forecasting systems, sharing data and expertise to improve global preparedness. Education and awareness campaigns are teaching communities how to respond to such events, ensuring swift actions to minimize impact. Beyond Earth, researchers are even exploring how upcoming missions to the Moon and Mars could incorporate protective measures against solar radiation, applying lessons learned from our planetary defenses. While solar superstorms remind us of the Sun's immense power, they also highlight humanity's ingenuity and determination to safeguard our way of life. These advancements not only shield us from potential disruptions, but also pave the way for future innovations in technology and science. Moving forward, let us explore another cosmic wonder, one that lies just a stellar stone's throw away, the fascinating and fiery Proxima Centauri and its unpredictable flare activity. As the next phase of this cosmic journey unfolds, ponder this: what if we discover another Earth, a planet teeming with all the conditions necessary for life? The search for such habitable exoplanets has captivated astronomers and dreamers alike, fueled by ever-advancing technology like the James Webb Space Telescope. While the scientific implications of such a discovery are monumental, the philosophical and societal impact could be even more profound. Imagine the questions that would ripple through humanity. Are we alone in the universe, or is there another world where life has already taken root? How would societies, cultures, and even religions adapt to this new reality? For centuries, we have looked up at the stars and wondered if we are unique. A twin Earth would not just answer this age-old question, but also challenge humanity to rethink its place in the cosmos. Governments and organizations might debate the ethics of reaching out to such a world. Should we send messages, attempt contact, or cautiously observe from afar? The implications for science could grow to include topics like interstellar travel and ecosystem studies, revolutionizing our understanding of biology and geology on a universal scale. But beyond science, this discovery could unite humanity in unprecedented ways. The realization that Earth is not alone might inspire global collaboration, reminding us of the fragility and rarity of life. It could also shift our priorities, motivating humanity to care more for our own planet while dreaming of new possibilities among the stars. Discovering a second Earth might not just be the next step in exploring the universe, it could redefine what it means to be human. Moving forward, we turn our attention back to a familiar yet mysterious cosmic entity. The spotlight shifts to Betelgeuse, a star whose unpredictable behavior has sparked intense speculation about a transformative and awe-inspiring celestial event. Now turning to one of the most captivating stars in our night sky, Betelgeuse. This red supergiant, located in the constellation of Orion, has been the subject of intense scrutiny and curiosity for years. At approximately 700 times the size of our Sun, Betelgeuse is a true cosmic giant nearing the end of its life. Scientists predict that this star could explode in a spectacular supernova at any moment, or in cosmic terms, within the next 100,000 years. But what makes Betelgeuse so fascinating is its unpredictable behavior. In recent years, it has undergone unusual dimming and brightening phases, sparking widespread speculation and a flood of scientific research. Some astronomers believe this variability might signal that the star is inching closer to its final explosion, while others argue it could simply be the result of massive dust clouds or surface activity disrupting its light. What would a supernova of this magnitude mean for us here on Earth? If Betelgeuse does explode, it would create a light so bright that it could be visible in daylight for weeks, perhaps even months. The night sky would be permanently transformed for a generation, with Betelgeuse temporarily outshining every other star and even rivaling the brightness of the moon. This event would offer scientists an unprecedented opportunity to study the life cycle of stars in extraordinary detail, potentially revolutionizing our understanding of stellar evolution and the formation of heavy elements essential for life. Meanwhile, some theories suggest that Betelgeuse's explosion might even result in the creation of a neutron star or a black hole phenomena that carry their own mystique and scientific intrigue. What if this cosmic drama reveals new insights about the fabric of the universe or the mysterious nature of space-time? While a Betelgeuse supernova poses no direct threat to Earth, its sheer scale and spectacle would undoubtedly leave humanity awestruck, reminding us of the immense forces at play in the cosmos. With this tantalizing possibility in mind, we now shift our gaze to a phenomenon much closer to home, one that could profoundly affect the very planet we live on. Let's explore the enigmatic and unpredictable nature of Earth's magnetic field and the possibility of its reversal in the near future. As the next phase of the cosmic journey unfolds, let us dive into an event of truly epic proportions, the eventual collision between our Milky Way galaxy and the massive Andromeda galaxy. While this monumental galactic dance is predicted to occur roughly 4.5 billion years from now, its implications stretch far beyond the sheer drama of two galaxies converging. What will follow this celestial merger is nothing short of extraordinary. As the two spiraling giants collide, the gravitational forces at play will utterly transform their structures, triggering bursts of star formation on a scale we can scarcely imagine. These newly formed stars, born from compressed clouds of gas and dust, could give rise to entirely new solar systems, potentially carrying the seeds for life in distant corners of the cosmos. Picture a sky densely populated with dazzling stellar clusters, reshaping the night views for any life forms lucky enough to witness the aftermath. Furthermore, the two central supermassive black holes of the Milky Way and Andromeda are expected to gradually spiral toward each other, ultimately merging into a single colossal entity. This dramatic event could release immense energy in the form of gravitational waves, rippling across the universe as a faint echo of this cosmic transformation. While the initial collision may seem chaotic, it is important to note that the vast distances between individual stars mean direct stellar collisions will be rare. Instead, the galaxies will slowly settle into a new, stable form, a massive elliptical galaxy, dramatically altering the local cosmic neighborhood. Speculating further, this merger could even pull in nearby smaller galaxies, such as the Triangulum galaxy, creating an even larger galactic structure. Such an event may forever redefine the layout of our cosmic region, demonstrating how collisions, while seemingly destructive, often pave the way for creation and renewal on an astonishing scale. In the distant future, any advanced civilizations that might exist in this transformed galaxy could find their skies filled with breathtaking celestial sights, a testament to the immense forces that shape the universe. While we reflect on this incredible transformation of cosmic proportions, let us now turn our attention to another phenomenon that showcases the universe's capacity for renewal and beauty: the appearance of a starburst galaxy and the surge of star formation that comes with it. With the next phase of the journey in sight, let us focus on the fascinating future of interstellar exploration, particularly the discovery and study of the next interstellar object. Since the groundbreaking sightings of Oumuamua in 2017 and Borisov in 2019, both of which captivated scientists and space enthusiasts alike, astronomers have been eagerly awaiting the next visitor from beyond our solar system. These interstellar objects, originating from distant star systems, carry invaluable information about the conditions and materials that exist elsewhere in the galaxy. However, the limited time available for observing such objects during their fleeting visits has posed significant challenges to fully understanding their nature. This is precisely where advancements in space technology come into play. In the coming years, the development of faster and more precise space probes could allow humanity to intercept and study these mysterious travelers more directly. Imagine the possibility of launching a spacecraft specifically designed to rendezvous with an interstellar object as it enters our solar system, equipped with advanced instruments capable of analyzing its composition, structure, and possibly even uncovering organic molecules or other signs of precursors to life. Such missions have the potential to redefine our understanding of planetary formation and the materials that contribute to life beyond our solar neighborhood. Moreover, future telescopes equipped with cutting-edge detection systems could help identify interstellar visitors much earlier, ensuring that scientists have more time to plan detailed observations and potentially initiate space missions toward these cosmic wanderers. Efforts are already underway to develop these capabilities, with space agencies and private organizations collaborating on ambitious new designs that could make the dream of interstellar object exploration a reality. Beyond the scientific breakthroughs, the study of these objects also expands our philosophical perspective, reminding us of the interconnected nature of the universe and the shared building blocks that tie our solar system to distant worlds. As we look forward to witnessing the arrival of the next interstellar visitor, the possibilities for discovery and wonder remain boundless. And as we marvel at this cosmic curiosity, our attention shifts to an equally exciting frontier, the launch of the next generation of telescopes, which promises to bring us closer to even more cosmic wonders waiting to be unveiled. With the next phase of the journey in sight, let us focus on the launch of the next generation of telescopes, a monumental step forward in humanity's quest to understand the cosmos. These advanced observatories, such as the Extremely Large Telescope and the Nancy Grace Roman Space Telescope, are designed to push the boundaries of what we can see and comprehend. The Extremely Large Telescope, with its colossal mirror capable of capturing light from the most distant corners of the universe, holds the promise of uncovering details about the first galaxies that formed after the Big Bang. This will not only deepen our understanding of how the universe began, but also provide insights into the mysterious force driving its expansion, known as dark energy. On the other hand, the Nancy Grace Roman Space Telescope offers unparalleled capabilities in identifying and characterizing exoplanets, those intriguing worlds orbiting stars beyond our solar system. By analyzing their atmospheres, this telescope could reveal potential signs of habitability, such as water vapor, oxygen, or other markers that suggest the presence of life. Imagine peering into the atmosphere of a distant world and finding evidence of conditions that mirror those of Earth, a discovery that would forever change our perception of humanity's place in the cosmos. Beyond these groundbreaking goals, the next generation of telescopes will also address some of the universe's most perplexing questions, such as the nature of dark matter, a mysterious substance that makes up most of the universe's mass but remains invisible and undetected through traditional means. With their exceptional sensitivity and precision, these observatories could finally shed light on this cosmic enigma, providing clues about its role in shaping galaxies and the universe itself. These technological marvels represent years of dedication, innovation, and collaboration among scientists, engineers, and visionaries, embodying humanity's unyielding curiosity and drive to explore the unknown. As these telescopes prepare to unlock the universe's secrets, we stand on the brink of discoveries that could redefine our understanding of existence itself. Moving forward, the journey through these fascinating cosmic milestones draws closer to its conclusion, but not before reflecting on the awe-inspiring interconnectedness revealed by these cosmic events and their implications for our place in the vast expanse of space. As the journey through these 15 cosmic events draws to a close, we are left in awe of the sheer wonder and mystery the universe holds. From the majestic return of Halley's Comet and the unpredictable power of solar storms to the groundbreaking potential of next-generation telescopes and the tantalizing possibility of discovering new Earth-like worlds, each event paints a picture of a cosmos alive with activity and intrigue. These predictions not only serve as a testament to human ingenuity and our unrelenting pursuit of knowledge, but also remind us how deeply interconnected we are with the universe. Every flare from a distant star, every whisper of dark matter, and every ripple of cosmic expansion tells a story that shapes our understanding of existence. As we envision these incredible milestones, the vastness of space invites us to reflect on a deeply profound question. What mysteries of the cosmos are you most excited to see unveiled in our lifetime? Share your thoughts in the comments below. We would love to hear your insights and imaginations. If you enjoyed this cosmic journey, don't forget to like the video, subscribe to the channel, and turn on notifications so you never miss another exploration of the universe's greatest mysteries. Together, let us continue our quest to uncover the secrets of the stars. Thank you for watching, and until next time, keep looking up.